cracking technical coding interview question. The question before us today says we should search 2D matrix. Now what that question says is, based on the specification of the questions, that the rows are sorted and the columns are sorted. It makes it easy for us to write a more efficient algorithm, efficient in the term of time and space. So looking at this, all the elements on the rows are sorted and all the elements on the columns are sorted. By virtue of that information, it helps us to see some insight into it. For instance, if we are looking for, if we come here to the last element here, 15, every element to the left of 15 will be less than 15 because the rows are sorted, and every element down in the column, every element in the column of 15 will be greater than 15 because the columns are sorted. So that means that if we are looking for an element and we start here at 15, if that element is now 15, if it is less than 15, then we should move to the left. If it is greater than 15, then we should move to the right. Then similar thing here, if we come in here, let's say we're here, if the element is now 19, if it is less than 19, we should move to the left. If it is greater than 19, we should move down. So one or two possible ways. So if you're in 12, if the element is less than 12, we move to the left. If the element is greater than 12, we move to the right. Let's say we're in 8. If the element is less than 8, we move to 5. If the element is greater than 8, we move to 9. So just like that, we can use that to traverse the array. So how do we code that up in the program? So let's go ahead and use the knowledge that we have had to code the problem. Okay. First, we handle the base cases as usual. That's essential. So if there's no matrix, then we return the matrix. Essentially, what we're saying here is that if our matrix is equals to this, okay, so we get a row, we get our row size as usual. This is common to every matrix problem. It's always defined as this. So we get our column size. It's always defined as this. This is common to every matrix problem. And what we now do is that we walk through we're looking for our target. We check if our target is equals to this, so we start from here. So this is 0, 1, 2, 3, 4, and this is 0, 1, 2, 3, 4. So to get the coordinate of this, the indices of this, it will be the length of the row, which is it will be the first row, which is 0, and the length of the column. So we will say y so we initiate our row, that our row is going to start from 0 and our column is going to start from the column size. But because of 0 index, we must not forget to remove 1 from that. So we say while our row, because we are traversing now, is less than the row size, and the same time, and our column is greater than 0, what do? We will check if the matrix of the row, which is 0, and the column, which is pass value, if it is equal to what we're looking for, then we return true. There are two possible ways if it is not. Else if we copy this, if it is greater, so this time if it is greater, what do? So we just go into our example. It's always good to use an example to walk through code. That's one thing I've understood that makes life easier in programming. So if it is not 15, so what do? So if it is greater than, if this value is greater than the target, then that means the target should be on the left. So that means the target should be here. So that means we what? We decrement the column. So because this is where we have this column, so to move from 4 to 3, we subtract 1 from the column. So we change the column to column -1. Else, the only other possibility, what do? If we are here and we want to go down here, that means we increment our row. We're in row 0, we're moving to row 1. So we increment our row +1. So if we have gone through all of this and we cannot find it, we just return false. So now let's do a walkthrough our matrix and see. So what's our target? So our target in this question is 5. So 5 is our target. So we pick 5 as our target. So what we do is we come in here. So this is satisfied. So our row size, will be equals to 5, that's length. Our column size will be equals to 5, that's length. So our column is going to start at 4, that's the end. So our row is less than the row size, so it's 0. 0 is less than the row size. Yeah, it's less than 5. And we check whether the column, which is 4, is it greater than 0. Yeah, it is. So by virtue of that, so I can mark this. So fortunately it doesn't want to mount. Okay. So based on that, so this is true. Then we come in here, matrix of our row. The matrix of the row maximize this so that we can see. So the matrix of our row which is 0. So matrix of 0, and the column is 4. So we check that. If it is equals the target, which is 5, so we have row 0, column 4, 15. So in other words, we're checking if 15 is equals 5. No. So now we come here, is 15 greater than 5? Yes. So we adjust our column. Our column, which was originally 4, will become 3. Okay, so we go back again. We know that 3 is still greater than 0. Okay, so this changes to 3, and we come here, this becomes 3. So row of 0 and 3, this is now 11. Is 11 equals 5? No. Is 11 greater than 5? Yes. So we move down. So we come in here to 7. So we know that our column, which is 2, is still greater than 0. And here we check matrix of 0, 2, which is 7. So is 7 equals 5? No. So is 7 greater than 5? Yes. So we decrement this to 1. So 1 is still greater than 0. And so we do the matrix of 0, 1, which is 4. So we check if 4 is equals 5. No. Is 4 greater than 5? No. Then we come in here to our matrix of row, and we increment our row from 0. Our row becomes 1. So we go back. Is 1 less than the row size? Yes. 1 greater than 0? Yes. So here we do matrix of 1, 1. So this is 1. This is row 1, column 1, 5. So it's 5 equals to 5. Yes, so we return true. Oh, so that's essentially that. So let's run our code and see how it works. Good. Let's test it on every other code. Oh, so we have a challenge here. Oh, sorry, we're supposed to return false. So that's a small error there. That means it's not there. Oh, what's going on? But it's a challenge, yeah. If not matrix is empty, and also we should check that the first element is also empty and not matrix 1. So let's test this case, see what's going on there. It is an interesting case. This is an interesting case. Good one. Oh, we should have column greater than or equals to 0. There's a bug here. Column greater than or equals to 0. Because we want when our column is also equals to 0 for these two actually true. So let's see that. Yeah. So this is the bug in our code. Yeah. let's see. Yeah. So we essentially don't need this anymore. So we don't need this anymore. Or if you want to put that, this should be all. Either of those. For this test case. Yeah, so it works. Or we, yeah, it's a good practice. So that we handle the case where we have something like this. Because this one, we handle this. But this one, we handle this case. Because it's possible that the first one is not, is empty. So let's see for all of them. Yeah, that works. Alright, so those are some edge cases to take care of, like this one and this one. Okay, thank you very much for listening and see you in the next one.